Okay, so this video we're going to get into one of the properties of matter, which we call density. But of course we want to be able to define these properties with a more conceptual, a deeper conceptual understanding. So we have this equation that you've seen before. The density is equal to the mass divided by the volume. Well, we want to really get into what does that mean? What does it tell us? If I were to ask you, well, what's heavier, brass, and I have this little brass cube. I have a scale here that will balance, if it's something heavier is over here, it shifts us that way. So if I say, well, what's heavier, brass, or let's say styrofoam? And of course that brass cube is heavier, it's tilted that way. And say, well, brass is heavier than styrofoam. Well, wait a minute. What if I do this? Now the styrofoam's heavier. So of course when we say what's heavier, what has more mass, really it depends. First of all, what has more mass? Well, it depends on the substance. What is the density, or how much mass does that substance usually have in a given amount of volume? And it depends on how much I have, how much volume is there, right? So right now, I've got more mass of styrofoam on the scale than I do brass because I have such a much greater volume. When we're looking at densities, let me move this. A lot of times we're going to be talking about gases. So sometimes solid, sometimes liquid, sometimes gases. So I have a little demo here. A lot of my demos involve fire. This one does. I'm going to set up a little ramp here. And at the bottom of the ramp, and I need to move my camera so you can see it. There we go. At the bottom of the ramp, I have a little candle. And so, of course, air has a certain density. It has a certain amount of matter in a given space of air. The density of air, as of course we'll get into much more as we move on through the course, the density of air depends on, say, the altitude, right? Air is more dense at sea level than it is way up in the mountains. And it depends also on what are the substances that make up the gas that we're talking about. So air has a certain density. This inside this flask is hexane. I'm swirling it around right now to build up some vapors. So the liquid hexane is there. So I'm trying to swirl it around so I get a lot of hexane vapors. Hexane is a lightweight fuel, very flammable. So if I take this hexane and I'm going to put it here, and I'm just going to pour only vapors down the ramp. That hexane vapor is more dense, and it comes up the ramp. So what I'm doing is, notice what's happening. So as I pour, essentially I could say pour. Can you pour a gas? Well, if it's more dense and you create a little path, it will come down that path. Whoops, and my candle is gone. Come on, candle. Or candle, you've been fired. New candle. Back to that. I don't want to burn this just once. I like to watch it. And it comes up the ramp. So the more dense vapor comes down the ramp because of its density, it will fall down through there along the ramp, hits the candle, and then the candle will light that gas. So the hexane vapor has more matter in a given amount of space. Let's move this out of the way right now. So we're going to explore density in this next lab that we have, and really get into this part conceptually, and then yes, we will be doing some calculations with that equation. In the lab, that's a part of the Google Docs, the procedures there with some questions. You're going to use, in your case, I have a glass graduated cylinder. You're going to use your plastic one. What I did in order to get a little easier at measurements, I gave you a magnifying glass so that you can really measure, because you need the lines on your graduated cylinder are marked for every milliliter. You want to estimate to a tenth, and it's easier kind of with this graduated cylinder. So you're going to weight your pennies. So I gave you the grad cylinder, no pennies. You're going to have to round up 15 pennies. Some groups got some pre-1982 pennies. Before 1982, the pennies were actually pure copper. After 1982, because copper is too expensive a metal, and a penny was actually worth more than a penny in its metal value, so they changed. So now the penny is zinc inside with a copper covering. So gather up pennies, make sure they're either all after 1982 and after, or before that, and get their mass. Weigh 5 at a time. And then what you can do is fill your grad cylinder. I've got this one filled to a certain volume. And I'm going to just look at, now how much water should you put in the grad cylinder? It doesn't matter. You just need a starting volume. Somewhere, towards the middle of this, I've got like 25.1. So when I'm reading my grad cylinder, here's my grad cylinder, it makes a kind of a little curve shape like this, meniscus, and right in there, you want to read at the bottom of the curve. So mine, I put in 25.1 milliliters of water. Again, the 25, so it's just barely above the 25, and I said just barely, so I'm going to go with 0.1. You need to go and estimate that tenth, otherwise you're going to have no significant figures in your value. And then I'm going to add 5 pennies. One of the way to measure volume, of course, the pennies I could say is roughly a cylinder, but it's much easier for something like this, anything irregular shape, to actually add some water and then I'm going to add 5 pennies at a time. 1, 2, 3, 4, 5. By adding the pennies, they have a certain volume. They're going to displace that water. And I check my water level again, and boy, it's just barely under 27. So now with the pennies in, the water level has moved up